Now let's discuss functions, and we've seen various built-in functions that Python provides, such as print and input and float and so on. But Python, like most other computer languages, provides a way for us to create our own functions. In a computer language, the functions that we create differ a bit from the math functions you're probably familiar with in math class. So those math functions take some arguments, perform a calculation, and return a value based on the arguments. But with computer functions, those functions may or may not have arguments, or we'll call these arguments parameters at times. And we've seen this with the print function. We could call the print function with no argument, and it just prints a blank line, or we could provide it with some arguments. Also, we may call a function because of its side effects, and we'll explore this more a little bit later, but we aren't interested in what the function returns, but what it does when we call it. For example, we might call a function to read data into our program. So it's going out to a file, say, and grabbing that. That's the side effect. The print function generates output. It prints something to the screen, but that's really a side effect. It doesn't return anything useful. So functions may or may not return something meaningful, and we'll get into the details of that in a little bit. Then the question is, how or why are functions useful? Functions allow us to use a divide and conquer approach where we can take a task and break it into smaller subtasks. As an example of this, let's say we have a really large task or problem we want to solve, and it requires the creation of a very large program. Maybe we're trying to do some climate modeling, and one of the tasks we need to do is read input. Maybe this is sensor data from current atmospheric conditions, and another task might be to initialize parameters within our model based on the data we read. And then another task might be to perform the simulation, try and make predictions about future values based on all that data we've collected. And then another subtask might be to generate the output. For that first subtask, we could maybe take care of that with one function. We'll just call it func1. This will read the input data, and we just have to focus on having that function do that one thing, and once it can do that, we're done. And then subtask 2, the initialization of the parameters, maybe that's a little bit more involved. We have two functions associated with that we create, func2 and func3. So maybe that subtask 2 could be divided into two separate subtasks. But then when it comes to performing the actual simulation, then maybe that involves the calculation of some values that function 2 actually took care of. So that function that we wrote for subtask 2, maybe it can be used in subtask 3 as well. So we see func2 showing up in subtask 2 as well as subtask 3. And then in subtask 3 we also say, well, maybe we had to write another function, call it func4 and func5. Actually, any valid identifier can be used for a function name, and we'll see that detail later. And then for generating the output, we might write a function func6. And when we look at this, we realize that there are some nice things about the way this is structured. We could actually have a team of programmers working on this, each assigned to a particular subtask, and they could work relatively independently, making sure their particular function or functions work properly. And later on we'll see about how we could get information flowing into and out of these functions so they're all talking together. And things are also modularized so that variables that are used within a particular function, we'll see that they don't interfere with variables that are used in another function. So if I want to call some variable just x in my function, that won't interfere with the variable x that you've used in your function that might be representing something different. So there are various advantages to using functions. First of all, they facilitate a divide and conquer approach where we could take a large, difficult problem and break it into smaller, more manageable problems. Also, once we've written a function, we can reuse it wherever necessary. So we put the effort into writing bug-free, wonderful functions. If we find that there is a place for them somewhere else in our program, we can simply reuse that, as we saw with that func2 in the previous example. Also, with functions, this facilitates working in teams, and there is this modularization as well, where we can ensure that what is done within one function doesn't interfere with what's going on in another function. Now, instead of using functions, we might try and tackle this task by just writing a huge collection of statements that aren't organized in functions. But there are all kinds of problems with this, that reusing code is difficult. We might try and copy and paste blocks of code if we find that they're needed in different places, but then if we need to change that code one place, we have to remember to change it other places. Working in teams is difficult if there's just a huge monolithic collection of statements. This modularization is lost, so if we have a variable x in one place, but then accidentally use x to mean something else in another part of our code, that could cause problems. So all in all, this is just a bad approach, and so I'm going to just jump back to the way we had things organized before in terms of functions. And that's what we want to explore next in the coming videos. How do we create and use our own functions?